Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Hello, let's look at another problem involving magnetic flux and Gauss's law for magnetic fields. Suppose you have a magnet arranged as shown in the picture next to a paper cylinder. Let's make a quick sketch of what the magnetic field lines would look like. So as we know, in a bar magnet, the field lines run from north to south. So something like that. I'll just draw several of these. So what you'll notice here is that the field lines, again, they run from north to south. So they point away from the north and towards the South Pole. So how do these field lines interact with the paper cylinder? Well, you can see that the field lines are penetrating the surface of the cylinder, okay, from the outside to the inside. Okay. So due to symmetry, you can see that this picture that I've drawn applies from every angle. Okay. So what will the sign of B dot dA look like for every part of this cylinder? Okay. So if you kind of zoom in, let's kind of zoom in on this picture, just at the surface of the cylinder. And let's use blue for B. So we can see that for any surface of the cylinder, the B field is pointing inward, but the dA, right, which is the area vector, the piece of the area vector is pointing out from the center. So of course, B dot dA is B dA cosine theta. So as long as dA has a component which is parallel to B, it's going to be positive. But if dA has a component which is anti-parallel to B, it is going to be a negative. So since you can see in this picture that the arrows are in general opposing each other, this is consistently going to be negative for all surfaces of this cylinder. Now, if that's true, if you add up the total B dot dA for the entire surface of the cylinder, you will get a negative value. Okay. Now, does this contradict Gauss's law for magnetic fields? It does not, because Gauss's law for magnetic fields is for a closed surface. Okay, and of course, if you look at the cylinder, a cylinder is not a closed surface. Okay, there are two openings here. Now, of course, if we took this magnet and moved it inside the cylinder, Gauss's law for magnetic fields would apply because the entire magnet is now enclosed inside this surface. So you have equal amounts of field lines going out of the cylinder as well as equal amount of field lines going into the cylinder. So in that case, the B dot dA would not be just negative for every surface. So in other words, for this particular scenario, there is no contradiction between our result for B dot dA of the surface and for Gauss's Gauss's law of flux for magnetic fields in general. Thanks for listening.